Balamurugan, I will be waiting for few more minutes, maybe 6:10. Then I will start the session. So quickly, I want to just introduce about what we are going to look in today's session. So there were some problems related to synthetic unit hydrograph reported by some students. So I have compiled those questions along with their solution. So I will be discussing those questions first, and then later I will quickly let you all that how we can collect the hydrological data necessary for computation of any kind of rainfall runoff model. If some time left, then I will also introduce about some of the models. Stochastic model, it may be a distributed model or maybe a lumped model or semi-distributed as well. So I will let you know what are those models. I will try to take you through their websites also, so that you can have some better understanding. See, the thing is, like, whatever things we have learned so far in this subject, it should have some implication into the field. We should be able to solve some of the problems which are existing in the field. So that's the target. Okay. So Balamurugan, I will wait till 6:10. I hope other students may join. Okay. Just for your information, I also want to mention that I have requested to NPTEL team to reschedule the upcoming weekly session to next Monday and Tuesday. So in coming Monday and Tuesday, I will be taking 2 hours both days to complete the leftover assignment portion in the course of engineering hydrology. Balamurugan, have you also got difficulty in solving synthetic unit hydrograph problem? Like from my side, when I saw those assignments for this session, I found that the questions were much more similar to what we discussed during the session. Okay, so I found that whatever the result it has been shown in the assignment answers, they are also the same. Are you also getting different answers? Like I already added that slide, that a screenshot of those questions. Those questions are related to assignment number 9, I guess, because just 2 days back on Tuesday we have taken our assignment number 10. So people were complaining, like people were telling that they are having some confusions in the answers related to synthetic unit hydrograph, question number 10, 11 and 12. Okay, I'm presenting my screen now. Balamurugan, tell me whether you are able to see this screen. Okay, that's good. Okay, so I welcome you all once again to the extra assignment session on NPTEL course Engineering Hydrology. So in today's session we are going to discuss few problems related to synthetic unit hydrograph. Those problems were already discussed in the earlier session, but just to make sure the calculations and the procedure to solve those questions, I again compiled those questions in this session as well, to have confidence related to understanding of concepts. After that, I will also go through the process, that is a procedure for collecting the hydrological data. What are those websites, what are the government portals that are available with us in India, as well as I will also try to add from other agencies from abroad, outside our country. Then if time left, then I will also quickly discuss some of the models, hydrological model, hydraulic models, which are available with us. Some of them are freely available, some of them are coming with the license. So we will quickly go through those things. Okay, so this is a screenshot I have taken recently from assignment number 9, where question number 10, question number 11 and question number 12. So these questions are related to a synthetic unit hydrograph that is to be solved using Snyder method. So in all these questions, particularly for question number 10 and question number 11, you can see that what are the information that is provided here in this question are almost same, but the required task is little bit different. So here I just want you to focus on some of the key concepts. So before proceeding to the Snyder method for generating a synthetic unit hydrograph, what we need is that two watershed, maybe watershed, maybe I am taking watershed 1 and watershed 2. Now there should be some similarity between these two watershed. In that sense, I just want to mention that watershed characteristics should be same. Okay, so there should be some similarity between watershed 1 and watershed 2. Also, we should have some hydrological data available with watershed 1, and we also have a condition that watershed 2 is not gauged. Not gauged in the sense we don't have any kind of information related to the flow, related to discharge through the main channel. That is the question, that if we are having a watershed with information of hydrological processes, as well as we also know that watershed characteristics are bit similar. You can say like geomorphological parameters may be similar. Morphological in the sense there may be streams in both the watershed. So in that case, if I will be counting the number of streams, so it may be possible that it may be a similar for both of them. There may be a slope parameter, there may be a length parameter, there may be a width of the river. So considering these parameters, we are found that these watershed are bit similar. So these are the conditions that we have to follow in this method. Now see, here in this question, watershed A is given and watershed B. For watershed A, we have information that 2-hour unit hydrograph is given, which was generated using observed rainfall and runoff. Also, if we see that the characteristics, so characteristics here it is given that basin lag, okay, time to reach the peak value, then peak discharge, maximum discharge which is reported in the watershed A, then total area of the catchment, then length of the catchment, then LC, that is the length representing the centroid of the catchment to the exterior boundary of the catchment. Now the question is being asked regarding the watershed B. Provided that watershed characteristics are same, but area is bit different, length is like nearly it is similar, then there is LC value related to 100 kilometers, and we have to generate synthetic unit hydrograph for 4 hour duration using this. In the next question, it is mentioned that we have to compute the time to reach the peak value. This is the question. So we will look into both of these problems parallelly, okay? So before going to this, I just mentioned in the earlier session also that there was some discrepancy in taking the length value as well as the LC, because just I mentioned that there should be a similarity in both these watershed. So in that case, whatever the length value it has been taken here, that is a 30 kilometer, and in the second case watershed B, it is taken 120 kilometers. You can see LC value here, it is 15 kilometers, and in this case LC is 100 kilometers. So it is somewhat little bit there is a discrepancy, like there should be value which should be like if I will be taking L, if I am saying that there is a similarity in the watershed characteristics, then L should be nearby, it should be 100 I can take, or maybe 110 kilometers, okay? And then here whatever the L value is given, LC value is given, it could be taken as 90 kilometers, okay? Then in that case, this entire assumption that we are considering that watershed characteristics should be similar, it will justify now. But if I am taking L is as equal to 30 kilometers and LC equal to 15 kilometer against the watershed parameters of B, L and LC, so it may like there is some major difference. So in order to counter that, the watershed parameters like L and LC should be nearby to 100 or maybe 90 kilometers. It should be in that sense. This question should be in those numbers only. Then all the conditions should be justified. But here whatever the values has been given, because of that case you may be getting somewhat different values, okay? So you should focus on the procedure part, okay? Procedure should be clear to you. What are the steps we are going through, that should be clear with you, and then accordingly you can change the values, okay? But logically you should think in that way, okay, that there should not be that much difference. See, if I will be saying that area is, instead of 700 it is only 250 kilometers, then if you take 250 kilometers and then if you compare it with 1200 kilometers, then that doesn't make any sense, because it is now having more difference, okay? So this should be logically you should think in that way, okay? Now based on these values are being computed. Okay, so here the data is mentioned here, that what are the data that are available with us. So for watershed A, basin lag, that is TP equals 24 hours is given, peak discharge is given for 50 meters cube per second, then area is given 700 kilometers square. Yes, okay, there is some difference in this, okay, yeah. So L is given 30 kilometers, then LC is 15 kilometer. Then for watershed B, where we need to derive synthetic unit hydrograph of 4-hour duration, having an area of 1200 kilometers square, and then length is given 120 kilometer and then 100 kilometers of LC value. So what is the step? So before going to the step, just quickly go through the synthetic Snyder synthetic unit hydrograph method. So in order to generate the hydrograph, we should have information related to duration of the rainfall. So in that sense, I just want to mention that you should have idea of the hydrograph of that catchment. Then you should also have the value representing the centroid of hydrograph to the peak discharge. You should have that value also. And then in order to justify the smoothness of that hydrograph, you should have values related to width of the hydrograph at 75% of peak discharge as well as 50% of peak discharge. You can see that basin lag, it is like defined as the time difference between the centroid of excess rainfall hydrograph and the unit hydrograph peak. Then peak discharge of the watershed per unit area is defined as QPR. Then base time is defined as TB. And then accordingly how we can compute the width at 50% and 75%, it is being mentioned. We had already covered some of the empirical relations representing that how we can compute these widths. Also, before moving to the question, we have to look properly into standardization of the unit hydrograph given to us, in order to see that whatever the duration of rainfall is given, it is getting, if I will be giving a factor to this, it should be equal to TP value. So this check we have to apply before deriving this unit hydrograph. So here watershed A properties were given to us. So what we did, firstly we have checked that whether this unit hydrograph is standardized or not. So this unit hydrograph was of about 2R unit hydrograph was given. For standardization, this criteria should be fulfilled. That means time to reach the peak value, it should be equal to 5.5 duration of the rainfall. If it is equal, then that means it is a standard unit hydrograph. But if it is not, then we have to make correction for time to reach the peak value. Okay, now it has been checked for this this relation. So TP have been calculated. So TP, how we have calculated that? So we have just taken a factor of 5.5 with 2 hour duration. So it was found to be 11 hours, which is not equal to basin lag. Okay, that was given to us, that is 24 hours. See here, it was given like 24 hours. So it is not equal to this. So definitely for that case, we have to make a modification in TP value. Time to time from the center of hydrograph to the peak discharge. So here TP was calculated by using this empirical relation. So 22 by 21 and taking a parameter of T NPR minus TR by 4. So what values we have in order to adjust the TP. So TP, how we are going to adjust? So we are going to adjust with initial value. Initial value was what? It was 24 hours. So we are adjusting this value only. That if it is not standardized, then what could be the change in this value? So now it has been adjusted. NR value, that was 2 hours, it was given. So 2 by 4, it has been computed like 24.619 hours. Then what comes next is that we want to generate coefficients for the known catchment, and then we will be transferring those coefficients directly to the ungauged catchment. So here for watershed A, we are measuring we are estimating the coefficients related to the time and coefficients related to a peak discharge. So how we can do that? So for computing that, empirical relation used by Snyder, it has been mentioned directly here. that are dependent on length of the catchment and LC parameter. Okay, provided that TP value is given, basin lab, it has been given to us. So using the CT value, this much of value was generated. So here TP value was given. TP value we have got here 24.619. Then it was multiplied by length, that is 30, and then LC value was also given. So it was coming 2.41 something. And then for peak, similarly we have computed for the peak. Then in that case Q and PR was given. So in order we already know that Q is, if it is a small q, then that is a peak discharge per unit watershed. Peak discharge per unit watershed. So that's why we were being given 50. So 15 meter cube per second it was given to us, and then we have divided this by watershed area, and now TP is being multiplied. Let me check anything you have replied. Okay, CT is 5.25 and CP is 0.6325. Okay, it was coming like that. That's the thing I was just asking for this. Okay, so CT you are saying that it should be 5.25. So what about the TP value? Firstly, confirm that whether the L and LC value that is given in the question is same for you also. TP is correct. Okay, TP is correct. That's good. Okay. Wait a minute. Okay. Yeah. Next, Balamurugan, what you are saying? TP is correct. Then that's good. Then what next? If I will be computing CT, then what is the difference in this? What is going wrong? Okay, do I need to recalculate it? Values are same, I guess. Calculation is like calculated value are coming wrong. Is it right? Let me calculate it also. Yes, Balamurugan, you are right. So computed value should be like, it is not coming like that, it is coming 5.25. Yes, that may be the case. Yes, okay, that's good. I got it. So this value should be 5.25 it is coming. Okay, now so what about the CP value? CP value is how much? 0.63. Okay, wait a minute. 0.63. Okay, this is correct. Okay, now moving ahead now. So the coefficients will be 5.251. It should be transferred here. Okay, and then rest is same. Okay. So Balamurugan, tell me whether what is the value TPR you are getting now if just we are taking a value of 5.251, because I guess that is why people were getting confused, because value was not coming same. 5.251. If it is multiplied, then for the remaining watershed B it is given 120 and 100. It should be having the power of 0.3. I guess it is now coming 65.926. Is it right? Yes, 65.9. Yeah, 65.926 something. Okay. Okay, once we will get this value, it should be 65.926, right? And then we are dividing it by 5.5. So if we will divide this by 5.5, then how much we are getting? 11.98. Is it? Okay, yeah, 11.98 or maybe 99 I can take. Okay, so now there should be change, because whatever the TR value we are expecting a TR value of how much? A 4R unit hydrograph. Okay, so here we have to put 11.99. So how much it will come now? Also we have to change this value, 65.926. Now compute this value, 65.926 subtracted by 11.99 divided by, it should be divided by, okay, yeah, Balamurugan, how much value you are getting? $63.917. Okay. Yes. Okay. Round figure. I am also getting 64 something. Yeah, not an issue. Okay, now we got T-PR modified value. Okay, now the next step is we have to compute the time to peak. So in that case we have to take 64.47 and it should be in that way. Okay, 64. How much, Balamurugan, you are getting? 66 something. It should be 47. Balamurugan, tell me. 60. Yes. Okay, no issue. Then regarding the QP value now, so what were the TPR? So TPR, what was the value we are getting? 65.93. I can take 65. 65.93, and if we are taking this value, and CP coefficient is correct, whatever the value was taken, it is correct. Now 2.78 to be multiplied by 0.6325 and divided by 65.93. It is coming 0.0267. Okay, it is coming 0.0267 I can take, and now it should be multiplied with the area given to us, right? So if I am multiplying this value with 1200, So I am getting approx 32 32.00 meter cube per second. Is it okay? That's good. Okay, so what was the answer given to this? So peak of 4 hour, it is coming to be nearly 32 instead of, okay, the range is given to 62 to 72. Okay, that is the problem they are also facing. So Balamuran, you also got the, what was your answer? Okay, 0.027 multiplied by 12. Oh, wait, what are you saying? 0.0. Okay, yeah, right. Yes. Okay, it is coming, yes. So what was your answer? Do you also get the wrong answer? So that accordingly now I have to discuss with them, because the calculation is okay. You are also getting the same answer. Okay, got it. Okay, now I will raise this question to them, like with them. The thing is like we all are facing the same problem, so that they can quickly solve it, solve this issue. Okay, so I guess if we are continuing to this problem for computing the time of rise or time of the peak, so like whatever the calculation we have done so far, it should be same. Okay, the thing will be the only thing that should be different is that whatever the TP, capital TP value was calculated, it should be coming in like as an answer of this question. Okay, so what was the TP we have calculated? 66.47 hours. Okay, so it should be coming like this. And yes, okay, so from my side I guess there is some like change in their order, like whatever the answer they are providing, it is just changing in their order. That is the thing that might be a problem. Okay, because 29 to 34 the range is given, and how much we are getting here in this question? 32. Okay, so it is coming in this range. I guess there should be some change in this order. And if you are seeing that time to peak, it is coming to 66 hour, so I guess this is also coming in this range only, 62 to 72. So I guess that is the thing, it is the problem, right, Balamurgan? Question number and answer number, yes, right, they are getting changed. Okay, now if we see the last question, so that is the 12th one, watershed A, and in this question time base is asked. Okay, so if we see for time base, so here the how we are computing this. So for the thing we need to compute QP, and QP, after computing the QPR value, it should be divided by, okay, so how much value was like we were getting at that time? Wait a minute. So okay, so QP value, peak discharge, we were getting around 32 meter cube per second. after multiplying it with area. Okay, so okay, we need to provide here a small q value, that is the per unit area value. So it should be nearly to 0.0227 something. 0.0267, yeah, in the round figure it should be this only. And now if we compute this value, how much we are getting? Okay, it is coming more than 100, I guess. This is the question number 12, sir. Question number, okay, this is okay. Okay, in your terms, okay, in that that fashion it is given. I got it. Maybe the order of question 95. Okay, it is correct. Okay, I guess question maybe it is having some more, different value, I guess. Time to this is a question number 12. Okay. Okay. Let me see the question first. Okay, that is related to 10 hour. I got it now. Yes. Okay. So the value what we are computing right now, it should be coming with regard to 10 hours. That is the thing. Okay, got it. That should be a change. Yes. So only thing we need to change is like NR value we are taking. That is the thing, it is being changed. 10 hours. Okay then. So should I move ahead to discuss some of the procedure, like some of the steps that we have to follow for computing for collecting the hydrological data? So I will be quickly discussing them. So till now, from the session 1 to 10, we have almost discussed all the parameters of hydrological cycle, starting from the precipitation. So mostly the rainfall we have discussed, then the temperature, then once the rain is falling on the region, how it is getting distributed over the area, how much part of the rain is getting infiltrated, and the remaining part how it is getting converted to a runoff and directly flowing through a river and meeting a major storage of the water, that is ocean or the sea. So after studying the water cycle, that how it is working in the water in the catchment scale, we should also have idea that we can model these processes. Model in the sense, you should think in that way that there should be a water balance. You should have idea that how we can compute the known parameters, knowing the sum of the parameters. It may be measured in the field or may have been recorded through any kind of digital instrument, so that we can establish the water balance, that we are knowing that how the rainfall is varying with the space, how the rainfall is varying with the temperature, and if there is a variation in the rainfall, how the other parameters will get influenced if the input values are changing, provided that the system response should be adjusted based on the field conditions. So here the first hydrological parameter I am discussing here is the rainfall. So rainfall is the primary input to any watershed or the catchment. Now in India, IMD, that is India Meteorological Department, coming under the Ministry of Earth Science, Government of India, it is collecting and sharing this data to whatever the concerned agencies is working on it. So there are a long network of rain gauge station which have been established by IMD across the India. They may be a recording type of rain gauge as well as non-recording type of rain gauge. It is mentioned in their standards is that for any catchment there should be 10% of recording gauges should be there. So now in this slide you can see that the link for getting the rainfall data in the form of grids is mentioned here. Why I am saying that it is a grid? Because the rain gauge station is gathering a point data, like it is gathering at a one point, but in order to get the influence of that rainfall at somewhat some distance away from the station, interpolation have been done. So interpolated data in form of grids have been given in this website. So imdpune.gov, they have given this data. So I can take you to their website. So firstly see, so this is the IMD website, okay. So here you can see that they are recording weather parameters at different scale, and they are also forecasting the weather with the time. Even they after recording the air temperature, wind speed, wind direction, solar radiation, all other parameters from their gauging stations spread over the India. They also predict the weather pattern. Also some of the time, depending on the pressure variation, they also predict the possibility of cyclone, or in some other words hurricanes is also called. So they are predicting those responses. So this is the IMD website. Here you can see what are their services they are giving to the public. See this whatever the data, IMD gridded data they are providing, it is free of cost for Indian users. But if you want some accurate data, like if you want the data from directly from the station, you want point scale data, so for that you need to make a request via mail and tell them that I need a rain gauge data for this area, provided the level of resolution in the terms of frequency. I'm just saying the frequency, like there may be a data you may be getting that for 1 day, or maybe it may be possible that you may be getting for 10 days or maybe 15 days. So depending on your requirement, you need to make a request. It may be possible that if that data is getting like coming under the area of classified data, then you should have to pay some of the some amount in that case, and then you can get that data easily. So now if you see the second link, so this is a direct link from IMD Pune, which have provided the database for gridded rainfall having a resolution of 0.25 to 0.25 degree. So this is a there is a grid having resolution of 0.25 to 0.25. So now you may be knowing that the conversion of 1 degree to kilometers, if you convert that 1 degree to kilometers, accordingly you should have idea that if I am getting a gridded rainfall, then how much area it is covering within 0.25 to 0.25 degree. You can see that they have given they have provided the data from year 1901 to till date to 2023, but this data will be downloaded in the file called netcdf file. So this is there are two ways to download this data, netcdf file as well as the binary file. Now this file won't be opened directly. It you need to convert this file first using any kind of GIS platform you can do, or maybe if you are having an idea of any kind of programming language, then you can sort this data for your purpose. Okay, so you can also read that what are the notes they have provided, and it is given that it is recording 365 to 366 records. Okay, varying from topmost latitude to the lowermost latitude, then similarly for the latitude as well. Now if we move to the next part, so similarly IMD also handles the temperature data. So they have distributed the temperature gauge stations across the India, and getting the point data first, and then they are interpolating that data in the form of grids. But here they are giving a grid size of 1 by 1 degree instead of 0.025. So in that case, for the rainfall, you are getting a final resolution of 0.25 to 0.25, and then here you are getting a maximum temperature or maybe a minimum temperature data for 1 by 1 degree. Here you can see that in this screenshot it is mentioned that 1 by 1 binary file it is mentioned here. So you can convert these files in your desired format using any kind of even you can use QGIS or ArcGIS or maybe any kind of programming language in order to filter out this data. Okay, so here for your information it is given that if you are using any kind of language, say it is mentioned that Fortran code is given, C if you are knowing C language, then C code is given, and then other kind of software information is also given here. Okay, now see, for any kind of forecasting or maybe weather forecasting, rainfall data as well as the temperature data is one of the key inputs. Okay, because nowadays people are, if we are in India, okay, we are here in India and we know that there is a two big oceans are covering this they are surrounding our peninsular region, okay, coastal areas. So here one is a Bay of Bengal, then other one is Arabian Sea. Okay. Now you may be from year by year it is passing, and you may be knowing one of the major word, that is El Nina or La Nina. Okay, El Nina and La Nina. So they are the you can say influencing our weather, Indian weather, or maybe I can say Indian monsoon significantly. And these are the, you can say that there are currents which are generating over the ocean, and these currents are passing through the atmosphere and influencing our Indian monsoon. So nowadays people are doing, people are researching that what is the correlation between Indian monsoon with El Nina and La Nina effect. Like how it will get changed, how will it get impacted. Like you may be listening that in the previous year total monsoon which should be covering the Indian region, it was bit less compared to the previous 10 years record. It has been found that it is getting lesser and lesser. But what weather forecasting agencies have told, that there is a significant effect of El Nina and La Nina in this case. So Indian monsoon is significantly altered by these external atmospheric system. Okay, now if we see that how we can get the river flow data, that is a stream flow discharge data. So for that case, there is a one government portal called India Varis. So from here you can get most of the hydrological parameters. They have compiled the hydrological processes over the India. Like it is not visiting this website and giving the inputs. Like you may be defining that I need the data for Gangetic basin, or maybe a Krishna river basin, Kaveri river basin, anything you can mention here. Even you can mention the district level data, you can mention the time scale, that from which year to which year you need that data. You can directly get this data from here. So firstly I am clicking this website. So here you can see India Water Resources Information System. So here many hydrologists or water resource planner or many hydrological parameter measuring agencies, they have compiled this data in this portal. So here what kind of data you can get? So see here you can get surface water. Okay, you can get surface water, then you can also get groundwater data, land resources, hydrometeorological. In that case you can see that rainfall data, evapotranspiration, soil moisture data you can get. And there are some more information related to any kind of report. If you want, you can get directly from here. Like there are many studies related to a drought, there is a studies related to flood inundation. So these kind of report you can also take information which is relevant to the things you are working on. So firstly, if you see that how we can get the surface discharge data, river discharge data, so for that you have to go through river section. Now in this river module you can get that there is a river monitoring. So in this river monitoring you are now seeing the entire Indian map with the location of stream gauging stations. Okay, so there are different colors have been mentioned representing a scenario, like you can see here. So there may be a stations which are having the level only, and there may be stations which are having flow, and it is possible that there may be some stations which are non-working, maybe during the non-monsoon season, but they may be working on the monsoon season. Then accordingly you can get those data. Now here there are many modules given to you, like basin wise you can get this data. Then there are many agencies in the sense you can get the data from state wise agencies. Okay, there are data from NIH, National Institute of Hydrology, Roorkee, and then there is a scale from at which scale you want to like you are requesting this data, and then starting date and stop date you can get this, and you will able to get this data in the form of like any kind of like editable format, like I will say Excel format you can get. Okay, doc. So this way you can get this river flow data. Now moving to the next, so that is next one is land use and land cover data. So there is a website from Bhuvan controlled by NRSC Hyderabad, which can provide you the long time series data for land use and land cover change across the India. So here you are seeing that National Remote Sensing Center, that is a part of Indian Space Research Organization. So they are providing the LULC kind of data for your study. Okay, what are their services? So you can see that Bhuvan service is there, data dissemination, how they are distributing the data. If you are requesting any kind of like foreign data dissemination program is also there. Then there is a Indian, and there is many like most of the time if you are working in the research domain, you get more benefit, because just like wherever in what organization you are working, you can get the more information in that case. Then there are information related to international disaster support, satellite ground station services, what they are providing. Resources is, you can see, you can go through this and you can see that what are the services they are providing related to agriculture, disaster management, LULC, soil. If I will click LULC, then see what kind of information they are providing, what are their portals available. But for your information, I have directly added the website, I have added the link to directly switch over to the Bhuvan portal. Okay, now you are seeing a Bhuvan portal. So Bhuvan Indian Geo platform for ISRO, which can provide you the land use, land cover data, provided that what are the satellites which are operated by ISRO, Indian Space Organization. So here there are data related to resource satellite list. Third, they may be like all these satellites, they are having different resolution depending on the level of resolution you need. Like it may be possible that you may be getting a like digitized or maybe a layer information with 56 meter of resolution. It may be possible that you may be getting 24 meter of resolution, 30 meter of resolution. So in the depending on the resolution you need, you can get this data. So resource sat, then hyperspectral images are there, then ocean sat, then cartosat. These are the satellites So they are having different resolution to capture those capture those pictures from the ground. Wait a minute. I received the LULC data like this. Okay, so yes, good. Okay, Balamurgan daily data, yes. Then this PhD for station wise data, sir, 15 minutes time for station wise, yeah, weather data, yeah, good, yes. So yes, you are right. So as per the instruction from the government, people are recording the data more accurately these days, because what is the major drawback in the field of research is that data, in like whatever the data we need, okay, that is most of the time it is missing. Okay, either it is missing or it is inaccurate. So in that case, DST, okay, Science and Technology, Ministry of Science and Technology, they have given strict guidelines to the data recording agencies that you have to keep the data like accurate as much as possible. Okay, related to LULC, yes, you are right, it is in the form of zip. Yeah, you are right. So how you have like requested this data? I guess it is if it is in form of zip, have you used Landsat data? See, LULC, if you are showing me a .zip file, then definitely it may be having a like multispectral images. Okay, and Landsat data is also there, which is handled by USGS, NASA. Okay, so they are also providing the data in form of spectral images. There we need to composite those layers, and then we can get the band of like band of composite layers, and then we can classify those layers. Like there are two kind of classification of LULC, that is supervised classification and unsupervised classification. So based on that you can classify that data also. But I am just showing you a Bhuvan portal, like Indian data, that how you can assess that data. So from ISRO also you can request, like just I mentioned that these are the satellites. So satellites are there, and you have to go through those satellite information, that what is the resolution, how much finer data they can provide to you, and once you are comfortable with the data you need. Yes, Earth Explorer, yes, USGS Earth Explorer, NASA data, yes, you're right. So they are also providing the DEM data, digital elevation model, and then yes, LULC data they are also providing with there may be a some time you are getting the data with some cloud cover as well, because there may be some white patches seen over the layers. Then at that time you need to make some correction that, because that is counted as a noise. Okay, so but just in the Bhuvan you are getting a digitized image. Okay, because research team in the ISRO organization, they are working hardly to gather this data as much as like at the finer scale. Okay, so you can just there is a process of requesting that data online, and if you are a researcher, if you are willing to go for research in the future, then you can get this data easily. Okay, for researchers there is no charge, but if it is commercial purpose, then it will be a chargeable. Okay, so just it is for the information, land use and land cover, how we can get this data. Then coming to the soil, so see this soil data you can get it from NBSS LUP. Okay, so this is National Bureau of Soil Survey and Land Use Planning. Okay, NBSS is located in Nagpur. So here you can also get the soil related data. So in the soil you can go through a section called Bhumi. So here you will be able to see what kind of data they are providing. So here district wise data, even tehsil level data, or maybe village scale data, you may access these data from here. Like see, you can see the data related to livestock census, then agroecology, satellite data product is there, soil fertility, then soil information, land degradation, and then land use planning. All kind of data you can get from here. Okay, just what you need is that you have to select whatever you want. Like if I am going for the soil and then I want the data at the scale of 1 to 50, then at that case it is asking related to which district you want. So if I am mentioning that I want for Delhi, then yes, it is now showing you whatever the possible soil pattern or data it can be. And then there is a scenario that metadata is possible, so you can request after selecting this. Okay, so likewise you can go for other parameters if you want. Like there are parameters related to agroecology, then multi-nutrient status. You can get these data easily from here. Now moving to the next. So see, we are now looking for the data related to groundwater. Okay, just mentioning one more thing, that if you want soil data from other, like outside our India, then there is a one organization working under the United Nations, that is FAO, Food Organization Association. So that is also compiling the data for entire world. Okay, so you can also go with that website also. Okay, so FAO, you can get the data in the format of ISRI. ISRI is just a GIS kind of platform. So in the form of TIFF file, that is a raster file, you can get that data maybe in the form of TIFF or maybe a SAFE file, SHP file. You can get that data, and for your study within India you can clip that using any kind of GIS tool. So FAO soil map you can also get from their website. So if we look into the groundwater level, if we want the groundwater level data in our India, so India Varis is providing this data as well. So what you need to do is that you need to go through this link, and then in the section water data you have to go through the groundwater data, and then in that case you can prefer water level behavior, and you will be able to see that what groundwater level data. So wherever their like groundwater wells they have like chosen across the India, you can get this data from this section. Okay, so what you need to do is that firstly you have to see that in which region or maybe in which state or district their wells are located. By selecting these sources, maybe you can have idea from Central Groundwater Board. Yes, if I will say you that related to a groundwater data apart from the India wise, you can also choose Central Groundwater Board data agency for data purpose. So from here you can also get an idea related to aquifer information. Like if you are unaware and you want to know the saturated hydraulic conductivity of the aquifer, or maybe transmissivity, or maybe a porosity or soil texture, you can
request this data from Central Groundwater Board. Okay, so they can also provide you that data, but at the same time they are also operating and managing multiple wells across the India. And if you request the data like time series data for water this water level, groundwater level, you can get this data depending on the availability. Okay, so for different states, groundwater agencies are working, and they are also aggressively recording this data based on the government guidelines. And if you want that any state data, you can request directly to them. Now see, one more thing I just want to mention is that quality. So most of the time some people are also working in the part of water quality other than the water quantity. So whatever the data just you are looking at that at now are all are related to a quantity. Okay, but if you are concerned, if you are working in the field of water quality, then you can also prefer groundwater quality. But yes, now again I just want to mention one more agency that is working aggressively in compiling the surface and groundwater quality, is that Central Central Pollution Control Board. Okay, so Central Pollution Control Board, it is directly managed by central government, but yes, it is also controlling other like state pollution control board, okay, across the India. So if you are interested in getting data specifically for Maharashtra, then you can approach in both agencies, like Maharashtra Pollution Control Board as well as the Central Pollution Control Board. So they can help you in providing this data. See, definitely they may be providing the data in certain ranges only. Maybe for related to quality, you may be getting a in situ parameters like what is the electrical conductivity, what is the pH, what is the dissolved oxygen, and maybe in most of the in few cases you may also get an idea related to a heavy metal presence, or maybe anions, or maybe a cations. But sometimes there may be some data which they are not directly mentioning or maybe publishing in the website, but yes, they are measuring that data. So if you don't get the data in the website, you can directly mail to them and ask that I need this data, and kindly can you help me out. You can approach in that way. Okay, so groundwater level I just mentioned. Okay, coming to the evapotranspiration data as well as the soil moisture data. So these data you can also get it from directly from the India Varis. So they are also nowadays they are just compiling these data in the website. You can request these data as well directly. But yes, you should be having some idea that we already studied that how we are computing the evapotranspiration data. So definitely you can using the parameters called like air temperature as well as the rainfall, you can compute evapotranspiration from empirical methods like we have studied in during our earlier assignment session. So there is one method called Penman-Montet that is aggressively used in this case. Pollution movement mass transfer. Okay, central. Okay, yeah, is not matched with Bhuvan class. Yeah, definitely, because the thing is related to a resolution. FAO is providing a resolution of somewhat 1:50K. Okay, so it is much more coarser compared to the Bhuvan you are getting. Definitely Bhuvan is also not providing that way. I guess they are providing in the resolution of 1:250K. Okay, but I guess in FAO you are getting 1:500K, something like that. So definitely coarser resolution is there for FAO as compared to, okay, just for the soil class. Yeah, And see, one more thing I just want to mention is that for the soil, it is not always possible that you are getting a digitized soil map with its properties varying layer by layer. Okay, so it may be possible that they may be providing you a topo sheets. Okay, so I already worked in the in Tapi River Basin, where data was not directly given to me in the form of any kind of like GIS format. Okay, so what I did is that I have digitized entire river Tapi Basin data for soil. Okay, compiling all kind of results related to canopy, related to depth of the soil layer, related to a texture of the soil. Then there are parameters related to carbon content, then how much percentage of sand is there, clay is there. So all kind of data I compiled at that time while I was modeling that basin. Okay, so yes, you may be at that time you may be provided with some of the books in the sense series, soil series books are being given for every state. Like for the UP state, you may be getting a soil series data, then you have to transferring that data in form of digital format. You have to convert that data, so it takes sometimes it may take time to prepare those data in order to get accurate result. Now the next one is central as well as state groundwater board also provide data. Yes, right, you are right. So groundwater observatories are there, state level as well as the central level. Pollution movement mass transport, yes, there are, yeah, of course. So there are many models which are working in this, like you can say Hydrus is there, then Modflow is also working in this domain. Okay, they are working in both quantity as well as quality. So firstly they are using the groundwater flow equation, and then they are adding the contaminant transport equation, that is advection dispersion equation, and accordingly they are trying to simulate that if I'm putting some kind of input concentration at the upstream, then what will be its behavior at the downstream, we can see in that sense. So yes, you are right, Balamurugan. So just we have discussed the, okay, so coming to the groundwater quality. So similar to the surface, you can also get the groundwater quality from various agencies like India Varis or this Central Pollution Control Board, state pollution control board. And then you can also sometimes while you are simulating the hydrological scenarios, there is a possibility that you are having a challenge of simulating the scenarios from reservoir, because in that case what you won't be getting a natural river flow. Because why it is happening? Because there are reservoir policies working in every every reservoir, because in that case, depending on the population, depending on the agricultural activities, they are distributing that water to the states. Okay, so there are reservoir policies. You have to incorporate those policies as well. In that policies, you may be getting that yes, during the monsoon, how much water have to be diverted at the downstream side, and during the monsoon, how much water have to be retained in the reservoirs. So you can get these data, and based on that, you can simulate all kind of hydrological processes getting changed with the time. So this was the things just I was mentioning. Now I just want to mention one or two more processes, models, famous models. So one is if you say related to a hydrological modeling. Okay, so hydrological modeling, there is one famous software called SWAT. Okay, so I'm just typing here. So I am going to the its interface. So there is a SWAT which is defined as a soil and water assessment tool. Okay, so it's like what are the things you can do is that you can simulate the entire hydrological processes using this tool, and with the time this SWAT model is basically working at semi-distributed scale. Okay, so it is not a lumped, but it's a semi-distributed. Why it is semi-distributed? Because it whatever the catchment you will be working, it is going to distribute it. It is going to distribute it in form of grids, and then you have to provide all additional parameters like weather parameter. Then yes, it is mentioned here, grids are there, then land use, land cover you have to define, soil map data you have to define, and then you can get the results. Okay, in that case. So just these are the documentation you can go through, and you can see that how it is working, what are the data that is needed. So some of the data they have already provided with India as well as outside India. Okay, then there are many publications which have been come up with the time. So starting from 1993 to 2022 to 2023, you can see there is a wide like acceptance from many authors using this software. Okay, so this is the one of the software through which you can generate the water balance. So just I am showing you one or two pictures. So after simulating all kind of things, you can get a picture like this. Okay, so precipitation is there, evapotranspiration is there, then root zone is there, Bordeaux zone, then shallow aquifer, confined aquifer. Okay, and then what are the return flow, lateral flow and surface flow is happening. You can see all these aspects. Also with the time, this initially SWAT was working for surface river water, like how it how the surface water is going to be distributed over the basin. But with the time, whatever the parameters for subsurface we are getting, like shallow aquifer or confined aquifer, mod flow model is clubbed with this. Like whatever the parameters we are generating after using this hydrological model can be transferred to the can be linked to the parameters related to mod flow, and then you can say integrated kind of study can be taken place. Now I am just showing you one more model for your, so that is a HECRUS. Okay, so see, HECRUS is also, sometimes it is free, but with the time it has also got licensed just because of adding some of the more modules in this. So here you can see that this model allows to user to perform one-dimensional steady flow, one and two-dimensional unsteady flow calculation, sediment transport, mobile bed computation, water temperature and water quality modeling. So here you can see that whenever the unsteady or maybe a steady kind of thing comes into picture, then there definitely hydraulics instead of hydraulic distribution of water will be taking place. Okay, so you can visit this software which was generated by US Army Corps of Engineers. Okay, and you can also see that whatever the publication and the work which have been done with the time. Okay, now I am also showing one more software, that is you are already knowing the mod flow. Okay, mod flow is just simulating the groundwater flow scenarios. Then there is a HYDRUS model which is working on the water quality. Then one more software is that HMS. This is a lumped model. Okay, so this is a lumped model for generating the, you can say, hydrological response from the basin. So it was also like made by US Army Corps of Engineer. So this is a HEC HMS. Okay, so this is a hydrologic modeling system. Instead of hydraulic, it is a hydrologic modeling system. So you can also go through this and see what are the, like what kind of result, or it's basically, just I want to add that these are the things depending on the your requirement, or depending on the type of things you are working on, you can choose these softwares or models. Okay, so after HEC HMS, there is one more software called MyC. Some of my fellow colleagues, they already worked in this using this software. So using the MyC, okay, so this you can see here, MyC is built on a coupled physics based model for overland flow, unsaturated flow, groundwater flow, fully dynamic channel flow, including all their complex feedback and interactions. Okay, so it also include the processes like vegetation based evapotranspiration, irrigation, snow and water quality. So this is also a more reliable software these days. People are working on this. Okay, and physics based in the sense, don't confuse with this. It's just a kind of simple physics principles which are working in the field. It is basically transferred to the model. Okay, so what if we are saying that mass conservation principle is working, so here in physics based model, mass balance as well as energy balance, it will be working. DHI mic not free. Yes, it is not free. Yeah, right, it is not free. It is a licensed one, plus or hydro. Okay, HRU based. Yes. SWAT is working on HRU based. Yes, right. Okay, so today I guess not other people joined, but yes, just I added few slides for more information, because see, this subject is now going to be wrapped up soon. Maybe 2 classes are left, but from the beginning, while I was just started this session, I was just trying to make the things at the local scale. Like whatever the theoretical concepts we are learning, it should be making more use in terms of application. Okay, so just I demonstrated some of the softwares or models which you can do. Okay, so Balamurgan, you are knowing these things. So like what actually you are doing at present? Are you a researcher at present?
Sir,
Hello.
sir, are you audible?
Yeah, I can listen you. Yes.
Yeah, I am here assistant professor in the Center for Water Resources.
Okay, that's good. Yeah, good,
Therefore, I
good,
am
good.
speaking to PG students also.
Okay.
So therefore, they are also asking about the hydrology
Yeah.
and how we can able to do that.
Okay,
I
that's good.
know, I know software programming also.
Okay, that's good. Yeah.
Therefore, I can quickly write the program and get the answer.
Good. That's good.
Therefore, a shortcut method I will use.
Yes.
Therefore, I can solve any simple problem to them. Therefore,
Uh,
therefore I have
yes.
the computer center
Yes.
and soft computing lab is for PG. Therefore,
Yes.
all these things uploaded in our system. So
Okay.
therefore, I am very familiar.
Okay.
Thank you. That is for students only. I am listening your
Good.
thoughts. It's very wonderful.
Yes.
Good going, sir. Thank you.
Yeah. Okay. Nice to listen from you. Good. Okay, then I will stop from today's point of view. we will meet on Monday, and we will look.
Monday,
Yeah,
same time, sir, 6
yeah,
o'clock.
6 to 8. Yeah, right.
Okay, thanks.
Yeah, sure.
Thank you very much. Good night, sir.